Good evening. Good evening, everyone. Okay, so now let us begin with. Oh, I have not uploaded my shared by screen. Okay, just give me a moment. Okay, yeah. Okay. So now what we will do is once again the same problem but a different flavor. Okay, let us see that. So towards it, we are now working on work energy theorem. In the previous video, we have seen how to apply work energy theorem as applied to particle speed, or the question we asked was, if suppose I want to find out the work done in moving a particle from x equal to 0 to x equal to b, the speed is proportional to square root of displacement. Okay. And the mass of the particle is 1 kg and it started from rest. This is what was the given information. You need to find out what is the work done. That was the question. So towards it, I was able to show the solution by three different methods. One is by kinematics. The second one is by the, what you call, integration method. The second one is the work energy theorem. And the last one is by the integration method. Okay, these are the three different methods which I was able to show it across here. But now, the next question is, see, since I have given here the speed is proportional to square root of displacement, then maybe I thought, okay, so why should it be proportional to displacement, square root of displacement? Okay, so why can't I make something like speed is proportional to displacement, or maybe displacement square, whatever it is. Why can't we have something like a generalized one? Okay, so towards it, I don't want to complicate. Let me show it for displacement alone. And when we have something called as displacement, then definitely the methods will also change. Okay, root of x, we have to use a different method. And if it is just x or anything apart from root of x, you cannot use the same method. Now let us see what difference do you observe. Now towards it, the first thing is, now when you say the speed is proportional to displacement, now let me write from here that v is proportional to x. Okay. In other words, removing the proportionality constant, I can write v is equal to some k times x. This is what I can write. So therefore, now what we need to do is we need to do by two methods or three methods. The first thing is you cannot use kinematics. Why can't we use kinematics? Let us see that also. You can use your equations of motion only when the acceleration is constant. Now, how do I get the acceleration from here? Let me differentiate this. dv by dt is equal to k times dx by dt. Okay, so this is for 11th and 12th standard kids. 9th and 10th students cannot do this. Okay, so dv by dt is nothing but your acceleration. Acceleration is equal to k times dx by dt. What is dx by dt? Velocity. So I can now write this as k times v. Okay, thus you see acceleration is not a constant. The acceleration is proportional to velocity. When velocity changes, then definitely acceleration will also change. That's what we have come to know. Okay, now maybe if you want, I will put this v equal to kx once again if you want. I'll write this as k into kx, which is now equal to k squared into x. Now don't get confused saying that this is an SHM. Okay, it is not SHM. Because if it was a SHM, then there should have been a negative sign here. Without negative sign, you cannot consider this as a SHM over here. Okay, because if you plot a graph of acceleration versus displacement, as the displacement increases, acceleration also keeps on increasing. There's no limit. Okay, there it doesn't happen like that. Okay, so as the displacement increases, okay, displacement and acceleration are opposite vectors. So we study a different, okay, way of describing things. Maybe later on, okay, in my future videos, I would like to make something on SHM also. Okay, now we are not discussing SHM. We are just discussing about this one. So when velocity is proportional to displacement, the acceleration is nowhere going to be a constant. Acceleration is equal to k squared times x. Okay, this is what we have. Now, what do we need? We need to find the work done. Okay, now first method, work done. What is work done? Force dot displacement. Okay, before doing this one, okay, can I apply equations of motion? You definitely cannot apply equation of motion. Why? Because you see acceleration is not a constant, and you can apply equations of motion only when the acceleration is seen to be a constant. So you cannot apply, okay, equations of motion. First method to gaya. Okay, you cannot use the first method. Now let us look at the second method. What is the second method? Second method. Now let us look at the, okay, let me write first method Okay, second method we are going to do. First method, m1 by equations of motion is not possible because I will use your internet language. Because what is that? Because A is not constant. A is not constant. I hope everyone understands that BC owes it. We are in the internet era, so we have used this. Okay, now let us look at M2. M2, what is M2? M2 is nothing but your work energy theorem. Work energy theorem. Let us see whether we can apply this or not. Work energy theorem can be applied at any point. Okay, so therefore, what does work energy theorem says? Work done is equal to half mvf square minus half mvi square. This is what it tells you. What is v of final velocity? What is v initial velocity? Now look at this here. V is proportional to x or v equal to kx. Now what is it given? Okay, the particle is still moving in a line like this. At x equal to 0, if I put x equal to 0 here, its velocity is 0. Its velocity is 0. Okay. When I say x is equal to b, at x equal to b, this is at x equal to b. At x equal to b, what is the velocity? I put x equal to b here. So this should be a times b. Okay. So what I will do is, now I will substitute here. I will substitute this as half m into, now here v final is nothing but k square b square minus half m into vi square. What is vi square? 0. So it should be 0 over here. So thus I can get the answer as half m k square b square. Why not? See how easily I got it, right? Work energy theorem. What did I do? I just put across these values. Put x equal to 0, find velocity here. X equal to b, find velocity here. And then substitute it. Very, very easy. No, I did not break my head. Okay, work energy theorem thus is a very, very easiest way of finding out the work done. Okay, now we have seen the first method, not applicable. Second method we have seen. Now don't tell me, see, second method we have done those. We just let us stop it here. Okay, I'm not going to stop here. Let me look at the third method also. Now, what is the third method? From the scratch. Okay, calculus method, integration method. 11th and 12th students can understand this. This method, even anybody can understand. Algebraic method. Okay, 11th and 12th specifically I say because I am introducing calculus once again here. Now what is that we have here? We have work done. Work done is equal to integral of x equal to 0 to x equal to b. X equal to 0 to x equal to b of f dot dx. F dot dx. Now what am I going to do? I'm going to write w is equal to integral of 0 to b of, what is f here? See, acceleration is k square x by this method, right? So therefore, the force should be equal to m times a multiplied by dx, right? So let us write this one now here, which tells me 0 to b of m to m into k squared into x into dx. That's what we have got. Now what I will do is put this here. Okay. Now m times k square x into dx. Okay. So now this m and k square are constant. Let me remove this. M and k square is constant. And thus I get an integral of 0 to b x into dx. Okay. Which once again, I will write here itself. Which once again, I can write this as m k square into, this is x. Integral of x is x square divided by 2. I hope you get this equation. What did I do? I use this equation, integral of x power n dx is equal to x to the power of n plus 1 divided by n plus 1. I use this. Okay. So therefore, I have this and then I have to apply the limits here, 0 to b. When I do this, what do I get here? I get this as m k square b square divided by 2. And then if I put this value of x equal to 0, it becomes 0. So thus I get this expression. Now see, I am able to solve it by work energy theorem, and also I am able to solve it by work done using integral calculus. Okay. The first I differentiated here. So it starts from this step. It's differentiated from here. I found out the acceleration, then substituted here, and finally I am able to arrive at it. Now guys, which is very easy. This method is easy. But you should also know how to solve the same problem using integration method. There are several methods in physics. It's not only this method. You have one more method known as Hamiltonian method. Okay. And you have one more method, was Lagrangian method. But you don't have it now. Maybe when you go for your master degree courses, then you will have it. Until your 11th and 12th, I think this is sufficient. Okay, so we have done it by 2 methods. Thank you, friends, for watching this. And if you like the video, do share this video with your friends and subscribe to my channel so that you get more updates. Thank you.